Hello and welcome to Great Expectation Tuitions. I'm Mr. Dionarine and I am going to be looking at proving the area rule in this video. This is a series of videos that are dealing with looking at the solution of non-right angle triangles. The area rule forms part of this section in the syllabus. So let's get started. Right. The area rule states that in any triangle ABC, the area is equal to half AB sine C. So let's look at this triangle. There's A, B, and C. So the area is that small a, B, and C. So half AB sine of the angle C. Notice that why this falls under our section of non-right angle triangles is that we can find the area without being given the perpendicular height, which we are so used to. Or we could say alternatively the area is given as half AC sine B or half BC sine A. You would notice that this rule uses the fact that we use two sides and the included angle in order to determine the area. Now I'm sure that this is quite a strange formula to you, as you have been so used to using our previous common formula that the area of triangle ABC is always half base times height. Well, we are going to use this in our proof in order to prove the area of the triangle. So let's look at the proof of the area rule. Right. In this triangle, we will be asked as follows. Prove in any triangle ABC the area is equal to half BC sine A. Now when we are given the example or the question like that, we look at the question and what we require to prove, and we notice that we have got sine of angle A. So angle A is placed in the standard position and our two other vertices is B and C as shown. Now in order to prove the area rule, we drop a perpendicular from point B to AC. Right? And we would call this our height. Now what we need to do is, if we look at the diagram, AC is the base of the triangle and H is the height. Now if we look at the height, and now let's look at the coordinates of B, especially if we look at the y coordinate of B. The y coordinate of B, as we can see from the diagram, is the same as the height of the triangle. So that would be the y coordinate of B. Can we determine the y coordinate of B? If we put in our sides of the triangle, that is C, that is B, and that is A. If we look at our diagram, we can see that we we can determine that H over C is equal to sine of angle A. So H is equal to C sine angle A. And this is equal to the y coordinate of B. Right. So we have the y coordinate of B, which is given as C sine A. Now let's go and look at the proof of the area rule. So in triangle ABC, as we stated, the area is equal to half the base times the height. As we said before, if you look up above, that AC is the base, so it is half AC times the height, which is H. Now if we substitute into our formula there, AC is B times H, which is C sine A. And if we rewrite this as half BC sine A, which is the area of triangle ABC. So we have proven that the area of any triangle ABC can be found as half BC sine A, the two sides times the sine of the angle between. Now this is very useful to use in non-right angle triangles and when we are not given the height of the triangles. We can apply this trig formula to determine the area. But what if we are asked to prove the area with angle B in the standard position? So all we need to do is rotate the triangle and we can show that the area of the triangle ABC is also equal to half AC sine angle B by rotation. And the third one is half AB sine angle C. So this is a very simple but effective proof for the area rule. Now if we look at the area rule, we apply it if no perpendicular height is given, meaning that if we're given the height of the triangle, we would use our standard formula, which we discuss as half base times height. Good. So let's look at how we can apply the area rule to some basic examples. If you look at number 1 in our exercise here, in our activity, we have triangle ABC with AB 40, BC 44 and angle B 36, which is the standard application of the area rule. We want to find the area of this triangle. You'll notice that the height of the triangle is not given, so we have to use the area rule. So we start by saying area of triangle ABC is half. Now, I would prefer to write it in terms of the sides, which is AB times BC sine of angle B. The reason why I'm writing it in terms of the sides of the triangle is when you have multiple triangles, then it is difficult to use the lowercase letters. Let's substitute. AB is 40, BC is 44, and sine of 36 degrees. Out comes our calculators for this here, and if you press this into our calculators, we get 517.25 centimeters squared. A basic standard application of the area rule, which I'm sure you must get right and get full marks for that. In our second question, question 2, we have triangle ABC with AB is 18, AC is 18, and angle B is 52 degrees. Now in this triangle, you will notice that we have the two sides, but we do not have angle A in our figure. So that poses a problem, because we did say that we needed two sides and the included angle. But if we closely examine the diagram, we notice that the 18 and the 18 makes this an isosceles triangle. So now it makes sense that we can say angle C is equal to angle B is 52 degrees. Hence, by sum of angles of triangle, angle A will be 180 minus 52 plus 52 degrees, which would be 76 degrees. So that solves our problem of getting the angle between the two sides. Now we can apply the area rule. So area of triangle ABC is equal to, what would you say? Half AB times AC sine of angle A, which is half 18 times 18 sine of 76 degrees. And what does that give us? 100, and if we put that in the calculator, 152,19 centimeters squared. So these are two basic examples which I wanted to do with you, and of course we are going to proceed to more difficult examples in these sections with past exam questions. So I hope you enjoyed listening to the videos on proving the sine rule, cosine rule, and the area rule. Now I'm sure you'll be able to approach these sections with confidence and be able to solve the questions that you will be faced with in the examinations. So bye for now, and till we look at the next videos, which will be our applications of the sine, cosine, and area rule.